All right, looks like the numbers are stabilizing, so let's go ahead and get started. Thanks everyone for joining today's CNCF webinar, Leveraging Kubernetes to Build a Flexible Self-Service Product Demo Environment. I'm Caitlin Barnard, Marketing Manager at CNCF, and I'd like to thank everyone who's joined us today. I'd also like to extend a welcome to our presenter today, Frank Reno, Technical Product Manager at Sumo Logic. So just a few housekeeping items before we get started. During the webinar, you're not able to speak as an attendee, so there's a Q&A box at the bottom of your screen. If you have any questions throughout the webinar, please feel free to drop them in there, and then we'll get to as many as we can at the end. This session is also being recorded, and we'll send that out afterwards along with the slides as well. So with that, I'll hand it over to Frank to kick off today's presentation.
Thanks very much, Caitlin. Hey, everybody, nice to meet you. Today, I want to talk to you about how we've been using Kubernetes here at Sumo Logic. We've got a couple of different use cases, but I want to talk to you about one that it's a bit different. It's one that I haven't really heard from. It's an internal use case. We're using Kubernetes to power our product demo environment. So before I dive in, I want to give you a little bit of an introduction to who we are. So we are a cloud native, fully secure, fully elastic managed service built on top of AWS. We ingest machine data in the form of structured or unstructured logs and time series metrics to really provide you a comprehensive and unified view of your modern application stack. We've got over 2,000 customers and 55,000 users spread across 6 different AWS regions. We analyze about 100 petabytes of data in a single day. Like every company, though, we need the ability to provide our potential customers with a demo of our platform to show how the product works and what we can help users with. It should be no surprise that product demos, they're a critical path in the customer lifecycle. They're how you introduce your potential customers to your product. They tend to go a bit deeper than your marketing material or your documentation to give customers a real glimpse into the power of your product. They're really designed to help educate customers on exactly what makes your product stand out from the rest. But many products can just be complex. Sumo Logic's really no different. We have a complex product ourselves. And you have countless number of use cases and features that you support, and you need to navigate through all these complexities to really show customers exactly what your product's intended to do. And to really help you navigate that complex journey, it's really good to have a driver who can help you and help the customer walk through the product, demonstrate the true power of it, and really what they can benefit from it. And at Sumo Logic, our sales engineers are those drivers. They demo the product to potential customers all day, every day. They navigate the prospect down that complex road, showing them a clear path on how the product can help them. What the product thinks of your product, what the customer thinks of your product after a demo can truly make or break the decision to purchase it. SEs really need a dependable environment in order to be able to successfully deliver their demos. And so, a few key criteria for any kind of really successful demo is that a demo needs to be reliable. SEs need to know that when they're getting on that call, their demo is stable, that it's ready to go, and it's going to work exactly like they expect it to. They need the confidence they can go through the demo without any interruption, and if they can't, your prospect may get worried or have some doubts about your product. The demo definitely needs to be comprehensive. It needs to showcase all areas of your product with a clear end and a clear beginning, making sure that journey is easy to follow and to understand. It also needs to be relatable to a story that you're telling, but more importantly to the story that your prospects are there interested in. It needs to be something that can relate to them, that they can tie back to their own needs and what they absolutely need. And flexibility is another key component as well. Customers are going to have many different use cases, many different needs. Not everything is one size fits all. The ability to adapt to these different situations is really critical. And so I want to talk a little bit of how we used to deliver our demos here at Sumo Logic. So we developed an internal tool called Logjam that enabled us to create streams of machine data in any format we wanted. And these streams could be sent to Sumo to simulate machine data from really any application or any stack. We could model known application formats such as Nginx or MySQL. We can also model common services like any one of the AWS services such as CloudTrail or S3 Audit. We could also model time series data, so CPU, memory metrics. We can model custom application metrics as well. And then really we could emulate anything we wanted. After all, we could model any kind of common applications that do a specific thing to tell a different story. And so previously we would put multiple streams together to tell a story. We could simulate real-world scenario from streams of these machine data using Logjams. We had a bunch of different demos. Maybe some told a security story or some operational story. And all these demos were different demos that the SEs would give to our customers. And so it was great. It was really helpful. It definitely got the job done. It was definitely something that we could demo the power of the platform to customers. And it was definitely met some of those key criteria, but it wasn't exactly what we really wanted. We wanted to go faster. We needed to have more. We wanted that next level up. So we really started to think about what we could do. But before we did, we needed to look at, well, what was missing? What were some of the key criteria? So we started having our conversations with our SEs to get a sense of how they were demoing, what were the strengths, what were the weaknesses. And it really boiled down to a few key points. The first thing was there was zero isolation between the demos. Everyone demoed the same exact environment. So there was no way for an SE to say, make some minor tweaks or changes that would really resonate with his prospect, with the person that he's talking to, maybe more so than another SE who was giving that same demo. You know, going back to this, it wasn't customizable, right? So they're actually, even if they had, you know, independent streams, there was no easy way for SEs to customize these Logjams. They were all pre-built. They were running somewhere they didn't have access to. It wasn't an environment they could really touch. They just saw the end product, really. And the other thing is that it wasn't really real. I mean, sure, we could model these streams to tell an interesting story, but we couldn't make it tangible. We couldn't go back to some real live application and show, yeah, this application is actually broken. So we started thinking about what we could do and what we wanted kind of the next generation demo platform to look like. You know, taking those pain points we identified by the SEs, we identified basically 3 areas that we wanted to address. The first thing was tangible. It came up over and over again. We wanted something that was real. We wanted an application that we could actually go to and use Sumo Logic to monitor it. We monitor its life cycle. We can show its health. We can show its state. We can show exactly how it's doing and what's going on. This is going to give us a much more real demo because we can go back from the application to Sumo. We can use Sumo Logic to troubleshoot that application and even bring it back to life. The ability to customize the demo was also a key critical component. Each SE wanted to be able to enhance or add things that they wanted to do. If they wanted to tell a different story, if they wanted to slightly tweak a story that made sense for their particular customer that they happened to be speaking with, it was important for them to do that. So we knew that the demo had to be customizable. But the last thing is we still had to, with all these new enhancements, we still had to preserve reliability. Sometimes SEs are back-to-back on demos all day long. They need to know that off the next call, they go to, off one call, they go to the next call, everything's going to run, everything's going to work exactly like they expected and exactly like they wanted it to. So we started thinking about, well, how can we get there? What can we do? You know, the Sumo Logic service itself is built on a series of distributed microservices running in AWS. That's been our architecture since we were born. We knew that we wanted to do something with microservices here. We learned a lot from it. We knew we wanted to take a lot of those strengths and incorporate that back into something that we could build into our product demo environment. We also knew we wanted to get into Docker and containers. It was something that we weren't using with our current platform. We were using it a little bit, but not super heavy. And we wanted to take this opportunity to learn a bit more, but we also like the flexibility, the isolation, the portability, the dependability that we get from containers and from Docker. But with all of these things, we knew there was going to be some overhead. And we didn't really want to have that overhead. We didn't want to have to be pushing this car uphill, constantly maintaining this environment. There's no real dedicated team here managing the demo environment today. It's actually managed by some of the SEs themselves. So it needed to be something they could easily manage. After all, their sole responsibility is to get on the phone with prospects and help them and get them introduced to the product and guide them along their journey as they start to discover the product. So it was really important they still had the opportunity to do that. We knew that we were going to need some level of orchestration. We needed some level of orchestration to help us maintain all of these microservices running in containers, help us maintain the environment, provide some automation on lower level things that could free up time with the SEs. And we started looking, and Kubernetes was coming up a lot at this time. This was probably almost 3 years ago, and obviously Kubernetes was coming up a lot. You know, I think everybody here knows what Kubernetes is. It's a very portable, extensible open source platform for managing your containerized workloads and services. And it's got a lot of great abstractions and services that kind of help facilitate these things. And we took a lot of advantage of those to build our environment. So we decided to go with Kubernetes. It was hot at the time. It offered a lot of great features, but there were really some key points that we liked that we wanted to exploit and to really use. Number one was the automation. Like I said earlier, it's a small team. It's a team of SEs, but they don't have a team managing this environment. It needs to be pretty self-service. SEs can be able to go create their own demos, make code changes, pushes out to their environment all independently to maintain that. We wanted easy scheduling. Obviously, that's a part of the basics of an orchestrator. We don't want to deal with the scheduling logic. We want that to kind of be handled for us. Scalability, we're growing, and as we were growing, we needed to be able to scale our demo environment out. As new SEs are onboarded, they're going to need their own environment. They're going to need their own playground that they can go build and play and tweak and make changes. And dogfooding. We like the dog food a lot here at Sumo, and we saw this as an opportunity to take a look at our architecture through a Kubernetes lens and say, what could we apply? What could we move our architecture to? What kind of changes could we make that we could apply? And this was an exercise, well, different use case, and not necessarily powering the Sumo Logic platform. It's very informative nonetheless, and we were going to learn a lot along the way, and it was knowledge that we could percolate back to engineering and share amongst them as we learn and as we go. So we took this as an opportunity to kind of learn a bit more about Kubernetes and see what we could do. I'll spend a little bit of time talking about some of the constructs of Kubernetes at a high level in case there's folks who don't know, but the core of Kubernetes is the Kubernetes control plane. It is the brains of the operation. It's kind of like the engine in the car that makes the car go. And it consists of multiple parts, but some of the parts of the API server, the scheduler, the controller manager, etcd. Each of these components serve as the control plane. They work together to provide the orchestration layer that makes Kubernetes what it is. I like to think of compute like if you're going with the car analogy, like it's like the tires of the car. And they're made up of a couple of things like your nodes. Your nodes are the tires in the car. Kubelet is an agent that runs in every node. Kubeproxy is another agent that runs on nodes. And you've got the container runtime, obviously, whatever your container runtime is. In our case, we use Docker, but Kubernetes supports many other container runtimes today. And then you've got your building blocks for your applications, for the things you're going to build. And these are the things that we really wanted to take advantage of, and we were going to build our demo environment with. Pods are the lowest level of compute within Kubernetes. They are a set of containers that are co-located and co-scheduled. Deployments give you declarative updates to your configuration. Daemon sets are really useful for agents, things that you want to run on every node in the cluster. Services handle how pods communicate with each other, and namespaces give you a logical grouping of how you can group resources together. It's not necessarily backed by the physical cluster, it's more of a virtual cluster. So I want to start with the end here. So we took all of these bits and pieces, we put them all together, and we built a product. But we're going to start at the end. This is travel logic. This is some screenshots from the application. It's a fairly simple UI. It models an e-commerce booking site, but it's fully interactive. You can go in and you can book a flight, and you can go through a payment process and check out, and you can go for the whole flow. And it's all running in Kubernetes, and this is all running in AWS as well. And now what I want to do is I kind of want to break this down a bit. I want to talk about each individual component, how we did it, and kind of what we did. And then at the end, we're going to go through a live demo. So starting kind of with the high-level architecture, namespace, the way we use namespaces is that's how we isolate the environments for each SE. So every SE's demo runs in its own namespace. And within that namespace, there will be a series of different services that make travel logic what it is. And we put together a lot of open source technologies, which will show layer, but you have some common things such as you need a persistence layer, a caching layer, some custom services like a checkout service so that you can simulate users checking out through the website, a product service to serve up what flights or hotels or car rentals we're going to serve up. There's an administrative UI which allows SEs to kind of fine-tune some things within the demo or make some tweaks from a UI perspective. Obviously, there's a UI service. And then we need to simulate like traffic against this site. This is going to be a real live application. In the end, we're using Sumo Logic to monitor that. We're getting all of that machine data. We need a way to kind of simulate that traffic. And rather than having Logjam, which we used to use, we wanted to make this real. These services were obviously real. If you took action against those services, like, made some REST calls to the product service, there was a log line generated, there was a metric generated. And so we use a task automation framework to help us simulate load across the servers, and that produces real live log data that's coming into the system. And then beyond that, that covers off on some of the components at a high level that make up travel logic, itself. But beyond that, there were a lot of things we still had to do that were done. Great, we had our application, but how do we deploy it? How do we maintain it? We built a proper build and deploy process, and it covers end to end from check-in to deployment to give SEs that customization. If they want to go in and customize things, they can go in, make a commit, it can go build their image, and it can push to their environment. And on top of that, we also found that we had to build in monitoring. So we were kind of customer zero when we developed our own monitoring solution for how Sumo Logic integrates with Kubernetes, how we pull the machine data from the orchestration layer, from your custom applications that are running in there. We use this exercise to build that integration. And it was a really good exercise for us to do. It gave us some hands-on experience, and we were able to really quickly learn what we could do and what were the best ways to get some of this data out of Kubernetes. And you'll see Logjam here. Logjam is still very much alive in our demo, but we've kind of changed its purpose. It has a much different purpose, which I'll talk about in a little bit. So I want to break down some of that travel logic layer a little bit more. All of these things I talked about, everything's running as a namespace. We have a bunch of deployments, and we're just basically stitching together a lot of open source technologies to leverage things. So we've got, for example, our persistence and caching layer, which we're just using MySQL and Redis for. On the custom services, so like the products that serve up the cars and the hotels and the flights, or checking out, things like that, we're using Flask. We're using the Flask framework for that. It was very easy for us to build some simple CRUD APIs and various APIs against, creating these products and going through an active checking out and going through the flow. I talked earlier about there's an administrative interface where users can go customize things. So we also use Flask in our settings service to kind of fine tune the demo. You can do things like control the load, control the frequency of errors, control the distribution of events to kind of change the flow of things. You can even go in and change like some of the logos or some of the branding. Like if you don't want to serve up, hotels, you could serve up something else. It's fully extensible that way. We're using Celery. It's an open source tax execution framework. That's what drives the traffic to the site. That's what, as we go through this demo and as I show you it, you'll see that there's actual events coming into Sumo. Obviously, people aren't going to that site and sitting there booking travel, but it is all the actual calls that are being made are real REST calls to the individual services that we have created. And the entire UI, the administrative page, and the whole front end is built on Angular. And then at the core of this, obviously, is everything's running in Docker containers, and everything has been put into Kubernetes and made to run as deployments. We've got services in between these layers that are talking to each other, that expose everything so they can communicate with each other. I talked a little bit about those common components that we had to build too, right? We need a build deploy process to kind of keep that automation going, to keep all that flow going, to make sure that SEs can quickly service themselves and push changes through and manage their own environments, really. And so at the heart of that is Jenkins and GitHub. Everything's maintained in a private GitHub repo, and Jenkins is powering everything. There's a Jenkins job for everything, and all the SEs have access to Jenkins, and everything they do that they need to tweak to their demo, they'll go through Jenkins, or there's an automated process that's picking up the commit and going through and pushing the changes out. So it depends on what they're trying to do. If a user needs to spin up a new demo, like a new SE started, part of his onboarding, he gets access to Jenkins, and he gets a document that explains how to go deploy his demo, and he gets his own environment up. And then from there, they can go tweak it and enhance it. And then the monitoring components are really critical. I talked about how we use this opportunity to develop our own monitoring solution for Kubernetes. And what we ended up doing is we built a FluentD plugin. We use FluentD to aggregate all the logs from Kubernetes across the control plane, across all of the nodes, enrich them with metadata, and ship them over to Sumo via an HTTP source, is what we call it. It's basically a secure URL that transmits all the data over to Sumo. And from the metrics, we also have an integration there with pulling in all the metrics from each of the individual instrumented components as they come in, which include CAdvisor and the API server, all the control plane components, kubelet. So we can capture all of these metrics and bring all of this data into Sumo Logic as well. And then, of course, we've got our infrastructure side. Again, this is all running in AWS. We are using, we used kops to create our Kubernetes cluster, and that's running in a region in AWS. And we're taking advantage of a bunch of other services here too, and we kind of tie them into our demo, but like things like VPC flow logs or CloudTrail logs. You know, because this is a real application, there's other services in AWS beyond EC2 that we're using, and we're kind of connecting the whole dots here, that this is a Kubernetes cluster, it's running in a cloud environment, and we're showcasing how we can bring in all the different data and all the telemetry from these different services. I talked earlier about Logjam. And it turns out it is still a very critical part of our demo product. So one of the things we have is we have what we call applications. And applications are basically pre-built content. They're usually built around some kind of technology. So for example, any one of the AWS services or Apache logs or MySQL logs. And these are pre-built basically searches and dashboards. So visualizations, taking this raw log data, identifying key things to keep an eye on and to look at and visualize that data. And so because Logjam could simulate any stream of data, we still heavily use this, and we use this to basically enable us to demo anything in our app catalog. We don't have to go set up an S3 bucket or define CloudTrail or go set up some, you know, physical hardware like with firewalls or anything. We can model what those logs look like because they're a known format. We know what the format looks like, and we can use that data inside of Kubernetes in our full demo environment to have this kind of single platform to demo everything that you can do with Sumo. So now I want to switch over to a live demo, and we'll hope the demo gods have been good today. So let me go ahead and come over here. So first things first, I have my demo running. I just want to show you kind of what's running here. So you can see there's a series of different pods here. I talked about we have MySQL for our backend, Nginx is serving up a UI. We've got some custom services like our checkout service or our product service. Settings and tasks are being handled. So again, those tasks are triggering all the load and simulating all that load across the system. And so now let's go to the final product here. So this is Travel Logic, and it's running on my page. And I can go through and I can actually book a track. Let's say I want to go from Denver, maybe to Sydney, take a short trip there. Now what I'm going to do is, now I'm going to break the demo. We've got multiple different demos that this can service, but I'm going to give you an operational demo. So I'm going to push a hotkey. Notice on the bottom there, you got a little OK pop-up. It's kind of a visual clue to the SE that something's happening. I'll continue to go through. We'll purchase this. Oh, gotta get my toolbar out of the way. I'll go ahead and pay. And I can see the payment was successful. Things are looking fine. Now, while we were sitting there, and after I pushed that button, a Jenkins job should have been running. Let's see if this works. Now I'll switch back to some of the slides to tell you the flow. What ends up happening is that a new Jenkins job gets deployed, and the Jenkins job is going to spin up some additional checkout pods. And so as the transactions are going through, we have one checkout pod behind the service, and as I hit the service, all the traffic goes to that pod. We scale out, and we deploy a new version of code. And as we deploy a new version of code, that code is going to have some inherent bugs in it that make it not work. Let me log back into Jenkins, apparently. There we go. So it looks like it's triggered. So this is the Jenkins job. We can go to the console output, and we can see that it was tied to cluster. So in this case, it's targeting my demo environment. And what we're going to do is we're going to push some new code. We're pushing dev code out. We're going to deploy 2 additional pods to that system if the Jenkins job finishes. All right, so while that's going, we're going to let that run. Another thing that we built into the demo is the ability to trigger jobs. So I talked about how SEs can go manage their own things. We've packaged everything up as Helm charts. So we've written our own Helm charts to deploy travel logic and to deploy the various things. But when we onboard a new SE, running and creating their own demo is as simple as coming in here, giving their name, and the Jenkins job will run, and it's going to go deploy that, and it's going to end up creating a new demo environment. In this case, it'd be freenode2.travellogic.info. All right. So now I want to jump to the Sumo Logic view. And all of these dashboards here, they're in live mode. So the data is being streamed in real time. All this data is coming in. And this is a representation of what we're taking from that data. So we're breaking down the travel logic business overview. We've got, you can see our flights, we can see our hotels, cars, we can see that everything's healthy. We can see where we're getting traffic from. Again, we're simulating that traffic using a task execution framework called Celery. But all these things are transactions that are flowing in. We can monitor for any kind of outlier behavior of what's happening, if there's any spikes or there's sudden drops in traffic data. This is another view of the operational demo. This is more high level to show you things, but this kind of shows how we are pulling in some of this real AWS data. So we've got our ELB logs, we've got our VPC network flow logs, and we were obviously breaking down our different services as well, bringing all that data in as well. And then we can even go so far as to break down service level information, right? So in this case, we can see metrics and logs here simulated together. We've got our custom metrics. We generate metrics in this application every time there's a booking, when it's successful or when it fails. We're monitoring the CPU of each one of the pods that are running in there. And we've got our gateway latency we can monitor. We can see if there's any errors by node. We can also see if there's any particular trends in the last 7 days. So we can see that all the time for the last 7 days, there have been no errors in the system. So that's good, that makes sense. That's what we want to see. Let me go back to Jenkins just to see if it has spun up yet. Okay, so it is in progress. Jenkins is running a little slow still. So I'm gonna let that finish up for a second. So a little bit about how we're collecting this data. I talked about how we build the FluentD plugin. So everything is coming in. We are running FluentD in this cluster as well. So if I do, let's just do get all pods. I've got a shorthand for this. And we've got a lot of pods running in this cluster. Every SE has their own environment. We've got some simple environments that we break at a scheduled interval, and some SEs have their own environment, like myself and there's several others that we can break on demand as we need to. But we run FluentD on every node in the cluster, and FluentD is sending in the logs to us and bringing in the logs with all the enriched data. And it runs on every node in the cluster, so we're able to get a comprehensive view of the orchestration layer and of the control plane layer as well. Oh, good. Things are starting to happen. So again, these dashboards are in live mode. So if I go back and I run this command again, you can see here that we started up some new checkout pods right here. Here are 2 new checkout pods that are running. This one is running for 5 hours. These are the 2 that are inherently broken. But again, they're all sitting behind the checkout service. And so if we go back to our application, to some of our reviews, we can see that, okay, we're starting to get some more failures. We go back to our business overview. We're starting to see some red panels light up here. We're starting to see some delay in our application status. We can even go to our operational overview. We're getting a higher number of ELB errors. Our checkout service is reporting issues, and if our checkout service is reporting issues, then we have problems. But wait, we just demoed this. We just went through and things worked fine. Well, again, it's all sitting behind the service, and some of those pods are broken. So if I go back in here, now what we should see is a failure, and it says error processing payment. So what just worked is now inherently broken. It's definitely not there. And from here, we can go now take customers through a journey of walking them through how to use Sumo to find the problem, to debug the problem, and to resolve the problem. And let's go take a look at that other job we ran. Refresh this. Okay, so that got done. So this might not be ready yet. Sometimes it takes a few minutes for a new demo to start up. So we'll give it a few more minutes so we can come back. Demo's not ready yet, but if we actually go look at the pods, we should see those running. Yeah, so there's Freenode 2. If you remember, I deployed it. I just added a 2 to my name. These pods are running. So the demo's still coming up. It's still being spun up. And once that's done and everything goes through, initializes all the setup and task jobs complete, we'll have a new Travel Logic demo environment that a user could go in and kind of troubleshoot. All right, so let's switch back to slides now. Cool. So I want to go back to the beginning of the presentation where I talked about our goals and did we meet our goals? Well, we have an application. It's definitely tangible. It's something that we can take customers through, show them a quick demo of the application. And all the data that comes into Sumo Logic is straight from that application. It's being streamed in to Sumo Logic. So it's definitely tangible, and we can break it. And we can, as we saw, we can actually see that break happen in Sumo. We saw that spike in failed bookings. We saw those errors increase. We saw panels start to change. And that's because we've deployed inherently broken code to the cluster, and real transactions are happening. And now those real transactions are periodically hitting one of those, two of those three broken pods. It is customizable in the sense that SEs can have access to the GitHub repo. They can go make changes, and they can push those changes to their environment. Their environment is isolated from every other SE's environment. They have full control over that. So if I want to go make some changes to the story, maybe I don't want to use a travel site, but I want to use some other e-commerce site or build something else, they have full control to do that. And over time, as SEs have done this, we've kind of prepackaged that stuff up and made it even easier for them to deploy. And they can easily, deploy different demos. We've got this demo I gave you is just one example of a demo, but we've got other demos that target different operational use cases or security use cases, and they've been customized and suitable to your needs. So we definitely met that goal. And for reliability, for the most part, we have had very limited problems with Travel Logic. It's like I said, we don't have a team sitting there monitoring it. We put really good things in place like horizontal pod auto scaling when we need to, vertical node scaling if we need to scale out the nodes. We have, or not vertical node, sorry, horizontal node scaling. We've put into place a lot of automation to ensure that things can recover. We make heavy use of like liveness probes and health checks so that we're constantly monitoring the system, and Kubernetes takes action against it as it needs and can help recover the system and cover off on a lot of use cases. And it's been a very reliable environment for our SEs to go to and to demo the platform to customers. So in the end, we met all these goals. We felt like we've met all these goals. And we learned a lot from this experience, and we started looking at other use cases. And one of the use cases we had was within our customer success team. So at Sumo Logic, customer success can be very different at different companies. Sometimes it's more aligned to the sales side, where they might be like on an account manager level. And sometimes they might be more technical. And at Sumo, that's the case. Our customer success teams are more technical post-sales arm that are very proactive in assisting customers. Going beyond a little bit of, sometimes beyond what PS does, we're here to be proactive arms to help customers. We monitor their usage, we monitor what's going on and how we can help them. And at Sumo Logic, we have a lot of decentralized data and tooling. We have, CRM data from one system, invoicing data from another system, our Zendesk and our various other, support-facing mechanisms. Lots of internal customization tools that have been built over time. And so we took an advantage to kind of move these things into Kubernetes. We took what we learned and automated a lot of things by migrating these, custom applications into Kubernetes and into also, bringing in various feeds using cron jobs and taking advantage of some other constructs that we could to bring all this data centralized into Sumo. And what it really helped the CS teams do was to provide this kind of single pane view for everything related to a customer, to help them monitor customers, to help them see how is this customer doing? Are they experiencing any slow queries? What's their adoption like? Are they logging in? Are they taking advantage of the system? Is there anything that any feature they're not using that might be relevant given some of the things that they're trying to do? And obviously, I talked about internal dogfooding, a next generation thing that we wanted to do. This is kind of an older version, but this is a map of all the different services that make Sumo today. And one of the things that we're looking at is moving our services to Kubernetes, and we're looking a lot at EKS, We like the automation that EKS gives us. We like the fact that everything's contributed back to upstream. We think they've done a good job with it. And so we're going to be looking at migrating slowly migrating our services over to EKS and kind of making that next level change to our architecture, getting it lined up that way. So if you take anything from this presentation away, I guess what I want to remind is this: Kubernetes is very versatile. We saw 3 different use cases. We were really focused on one, right? Our product demo environment. And the goal there was to build a fully self-service, flexible demo environment for our SEs to really use the power of Sumo Logic and to showcase the power of the platform. And because of our existing tooling and what we learned from Logjam, we made a lot of decisions along the way to really enhance our environment, to make it a little bit more flexible, to make it more tangible, and to make it even more reliable than what we had. And that was our sales engineering org. But we also found use cases internally for our customer success organization. And that enabled a lot of things to where it actually wasn't just customer success who was using it, but it was other teams that started using these centralized environments as well. Engineering and product. Engineering could look at the health of the app, the service across everything. Product could look at feature usage and compare that back with customer information. Sales could monitor the health of their accounts. They could make sure that their customers are using the system, that they're happy with the system. And then, of course, our engineering use case of where we're actually going to start migrating our services into Kubernetes and making sure that we're taking advantage of that next generation architecture and keeping our architecture on point. And that's it for my presentation today. I wanted to say thank you. Thanks for joining today. And I hope you consider other use cases for your environments and for different things you can do with Kubernetes too.
Awesome. Thanks, Frank, for a great presentation. So we have some time for questions now. Just as a reminder, if you have a question that you'd like us to answer, please drop it in the Q&A tab at the bottom of your screen, and we'll get to as many as we can. All right, so there's some questions coming in. So in the demo, is the workload being deployed as a deployment object or via replica set?
Deployments in all cases for all the stuff that we created, yeah.
All right. Another question. What is your strategy for cleaning up old demos to keep costs down?
Very good question. So one of the things that runs in the more common framework is we built some tools to look for long-running things. We do this kind of proactively in some cases, like for example, when an SE is off-boarded, but we also basically make it so that an SE can only have one primary demo that's allowed to run all the time, and the others have a time limit. And we basically have a process that runs inside of Kubernetes looking for things that have expired and doing that cleanup. One of the things that we want to do kind of next generation too is that we don't do a good job of today is kind of downscaling on the weekends. You know, our SEs aren't giving demos on their weekends typically. So that's something that we're going to be looking at incorporating now. We've got some ideas on how to do that based on what we've learned from the other cost maintenance, but that's definitely something we have some of, but I think we could still do a better job.
All right, and how do the salespeople provision the demo environment?
Let me go back. So I kind of touched on that briefly when our live demo was having some slight pain. So it's basically a job in Jenkins for them to go do this. So they can go to manage travel logic, and basically they can just go in here, and the namespace translates to their name. So if we have a new SE, Bob, who joins, he would enter his name here, push build, and that's going to translate to a demo. Earlier, I kicked off a job, and it seems to not have worked for whatever reason. Yeah. Something's going on with Jenkins apparently, but that is exactly how they go deploy it. So if they need a second one, they can go do that and they can control that. But everything's done through Jenkins.
Awesome. Another question: how will Kubernetes work with a monorepo, and is that a good use case?
How will Kubernetes work with a modern repo?
A monorepo.
Oh, a monorepo. There are, from our own experience with using a single repo to power this all, there are a lot more hoops and hurdles that you have to jump through, and it really boils down more to what Jenkins does because everything's powered in Jenkins. So we've had to develop a lot of custom scripts to handle various things. I wouldn't say it's as flexible there. It has its quirks and its issues there. We thought about separating it out. But we haven't made a decision either way. What we have today works for us, but at a certain scale, we're probably going to have to reevaluate that.
All right. And have you open sourced any of these demos or have any examples online?
Currently, we haven't, but that's something that we've thought about and we're still thinking about. We would need to make some tweaks and some changes to some things just to pretty some things up a little bit, arguably. But it's something we're not against. I think that we could certainly look at doing that, and that's something we can definitely take back to the team and talk about internally. We've talked about it before, but I think we should maybe take a harder look at that. I think particularly if you can run it in your own environment and you can do the same demo with Sumo Logic, I think there's a lot of value in that, right? Like if you give something to your customers and they see the demo, but they can actually go run the demo on their own, there's something tangible there. There's something they can wrap their heads around a little bit more. So I think it's definitely a good thing.
Great. So does each demo create a new namespace, and is that managed with RBAC? So each team has a namespace to deploy their demo.
That is correct. So every demo will run in its own namespace, and we have RBAC to control who has access to what demos. That kind of helps us preserve the isolation, make sure nobody's messing with other people's demos or no one accidentally deletes somebody else's demo. In general, the SEs don't actually use kubectl. They don't actually use the command line. Everything they do is through Jenkins, and so we have some enforcement there to also enforce what happens there. But in the end, when you run those Jenkins jobs, everything's just being deployed as a Helm chart too, and all that's prepackaged for them running in their own namespace and with the right RBAC settings.
Awesome. Another one, is the demo built on top of several clusters, and how do you handle auto scaling?
We have a single cluster right now for the production environment, and some of the SEs who want to build more things and kind of like play with things, or we're going to play with upgrades or changing in technology. We have a dev environment that we use for that, but that's a limited subset, and that's a much smaller cluster. The production environment for auto scaling, the thing to remember is that it's a different use case. It's not we're not like having a huge spike in traffic like regularly. We predictively know when we're going to hire a new SE, and we can monitor those things. We do have some scaling in place. We take advantage of a horizontal pod autoscaler for certain things, and node autoscaler to an extent. But if we onboard a bunch of new SEs, like we might have to go, tweak that ourselves. But there's an onboarding process, and so we know when a new SE comes on. We can kind of look to see where the health is. We have, and in that same environment that I demoed, we've got some monitoring set up internally to monitor the health of Kubernetes, making sure there's no issues. And if there are issues, we can take advantage of that. And some of those alerts go to a Slack channel that we monitor, and we keep several people who have access to kind of maintain the whole cluster, monitor, and maintain the health of it.
Right. And how will Kubernetes interact with smart contracts through block apps?
Not sure I understand the question.
All right, if you could provide a little bit more clarification, we'll get back to this one. Let me just get this next one lined up. How do you grant access from Jenkins to the API server?
If Jenkins is running inside of Kubernetes. So we are running Jenkins within Kubernetes. Kind of a chicken before the egg thing, I get it, but it's worked for our purposes. The slaves basically come online and run. What we're thinking about doing, though, is running Jenkins on an EC2, a separate dedicated EC2 instance, running the Jenkins master there, and just opening up a service that can so that we can deploy the pods to the API server. There's a great Jenkins plugin that we use. I actually don't know the name. It's just like the Jenkins Kubernetes plugin, to be honest. I don't know that there's that many of them. And that's what we take advantage of. So it does everything there. And then we just use the Jenkins Helm chart out of box. Having Jenkins inside of Kubernetes has some flexibility, but you sometimes get into these like chicken before the egg problems, which can be fun to deal with. That's why we're thinking about moving the master out into like a separate EC2 instance.
All right, if anybody has any more questions, feel free to drop them in the Q&A. All right, looks like we might be at the end of the questions for today. If any of you do have questions after the fact, please feel free to reach out to webinars@cncf.io. The recording and slides will be shared later today. Frank, anything else from you before I close this out?
No, thank you very much for the time, and thanks for joining, everybody.
Awesome, thanks everyone. And this is our last CNCF webinar for 2018, so we hope to see you at a future CNCF webinar in the new year. Have a great day.